Let's solve for sine of cosine inverse of u. This is a composition of trigonometric functions that we can solve using a right triangle approach. Let's break this down step by step. First, let's understand what cosine inverse of u means. If we let theta equal cosine inverse of u, then cosine of theta equals u. Now, let's draw a right triangle to visualize this. In this right triangle, we'll make the adjacent side over the hypotenuse equal to u, since that's the cosine of theta. If we make the hypotenuse 1, then the adjacent side must be u. Now, we can use the Pythagorean theorem to find the opposite side. If the hypotenuse is 1 and the adjacent side is u, then the opposite side must be the square root of 1 minus u squared. Now, remember what we're trying to find. Sine of cosine inverse of u. In our triangle, sine of theta is the opposite side over the hypotenuse. Since theta is cosine inverse of u, we can say that sine of cosine inverse of u equals the opposite side, which is square root of 1 minus u squared, over the hypotenuse, which is 1. Therefore, sine of cosine inverse of u equals square root of 1 minus u squared. Note that this is only valid for u between -1 and 1, which is the domain of cosine inverse. And that's how we find sine of cosine inverse of u using a right triangle approach and the Pythagorean theorem.